Solving for a right triangle basically means that you want to solve for all of the sides and angles of that right triangle. So, for example, how would you solve for an angle given two sides? The way to do that is to use inverse trig functions. And that can be written as this form, which shows to the -1. Now that doesn't mean that's the exponent. So in this form, I would know that the sine inverse of y does not equal 1 over the sine of y. First important piece to note. Second of all, the way to get from the sine of theta is equal to y to the inverse is you could take the inverse function of both sides actually. And when you do that, you're going to get theta is equal to the sine inverse of y. Now, that's one way to think about getting inverse. You're taking the function of both sides. Second way that you could get this is just by memorizing when you have the sine theta is equal to y, you switch the x and the y, kind of like the domain and range, and you add the inverse notation. To solve for certain problems, this one's easy enough because you have 60 degrees, so you know it's a 30, 60, 90 triangle. And once you know that, finding this side is going to be relatively easy, and you know that that's 30 degrees and that's solved. But a lot of times you don't have that, and so this is actually solving the whole triangle instead of just x, but you could solve for x just as well. If I wanted to solve for x in this problem, you're going to see that here's your angle, this is your opposite, this is your hypotenuse, and your adjacent, and what's given is the opposite and hypotenuse. That means that the SO for SOHCAHTOA is going to be what you use. Sine 25 equals 8 over x, and now what I would do is just create a proportion by putting that over 1 and cross multiplying and solving for x. And then you would just do that calculation. Now another type of question is going to be where you have to solve for all of the sides and angles of a triangle. For example, in number 3. Given this angle is easy enough. You just take 90 minus 56, which is 34 degrees. And you could use either angle, but I like to use the initial one just to keep it consistent. And I'm given my adjacent. This is my opposite and hypotenuse. So I can see it's going to be cosine of 56 is equal to x over 63.1. Again, cross multiply, solve. And get your x value. At this point, you could use the Pythagorean theorem to get your O, but it's better if you actually use exact numbers. So I would look at this and think of sine 56 is equal to y over 63.1. And again, cross multiply and get y is equal to 63.1 times the sine of 56, and then you get your y value. Now, if, for example, this 26 is not given and you want to find your theta, and this is, let's say, 12, the way that you would do this is to notice that you have an opposite over an adjacent, and this is your hypotenuse, which we don't know. Given these two, you know it's going to be tangent, so it's the tangent of your theta equals 12 over 19.2, and now you would do the tangent inverse is equal to your theta. Plug that in your calculator and get your answer. Two other concepts that go hand in hand are the angle of elevation, angle of depression. Both of these are going to be horizontal lines and the line of sight. And this right here, I like to think of as the sight line, the eyes of the bird, eyes of the dog. And so it's the angle that's formed by the horizontal and the sight line. So eye level, or I like to think about it as horizontal line. Horizontal and the sight line. Now, these two angles are actually congruent because of alternate interior angles. You have two parallel lines and alternate interior angles are congruent. But the most common mistake is that students will label this angle as the angle of depression because you want to place it nicely in a right triangle. However, it's outside of that triangle. It would be formed by this horizontal line and the line of sight. So be careful not to make that mistake. This shows how to solve for a right triangle as well as some definitions of the angle of depression, angle of elevation.